Hello everyone, my name is Amiya Dwivedi, Assistant Professor at Maharishi University of Information Technology, Noida. Today I am here to discuss a syllabus from MCA stream, which is Discrete Structure and Automata Theory. Why Discrete Mathematics and Automata Theory? As you know that computer science is all about automation, and automation required some machines which works automatically. Discrete mathematics develop reasoning and logic behind each and every computing. So it is very important topic in terms of computer science as well. It is used to develop reasoning and logic in mathematics. So let us start the first topic, which is mathematical logic. First of all, proposition. What is proposition? As you know that statements, you already know that the statements. Here what we are going to do, we are going to develop logic which can be implemented on machine. Definitely when we want to develop logic for machines, we must need mathematics, right? So discrete mathematics is the only thing which provide mathematical logic for machines. Propositions. Proposition is a statement that can either true or false, which makes some sense. Proposition is a statement that can evaluated as true or false. It is either true or false. For example, Delhi is capital of India. Delhi is capital of India. It is either true or false. It is true. Okay. 5 is less than 7. It is false. It is true, definitely. 25 is greater than 56. It is false. All these three statements are either true or false. That therefore these can be taken as a propositional logic. But the fourth statement, which state that how are you, it is neither true nor false. It is a declarative sentence. So it is not a declarative sentence. That's why it is not a proposition. Now, proposition are represented by variables like P, Q, R, etc. Any terms you can use for that. What are atomic and compound proposition? Atomic propositions are those propositions which have single statement. For example, the sun rises in the east. It is a single statement. It is true or false. It is true, as we know that. And 5 is greater than 3. It is also true. It is also a statement, atomic statement, or single proposition, simple proposition or atomic proposition. Now, sometimes we have to combine all these propositions to a single proposition to make a compound proposition. For example, the sun rises in the east and sets in the west. In this case, the sun rises in the east, if we denote it by P, and the sun sets in the west, it is denoted by Q, then both propositions can be combined together with some symbol. We will discuss all the symbols in further in this video lectures. P and Q, which is compound proposition. Now, what are logic operators? As we already discussed that compound proposition have multiple simple propositions, right? So what we have to do here, we have to use some operators, logic operator. Definitely it was, they all are logic operators. We have to use logic operators which are used to combine single propositions to make them compound propositions, right? So what are those operators? Let us start. First one is negation. What is negation? Negation is not of, logical not, it is not of anything. So if there is a P is a proposition, then its negation is denoted by negation of P. What is negation of P? Or sometimes it is written as negation of P. This symbol or this symbol is used to denote negation. Now, what does negation means? Negation means, if we truth table, truth values, every proposition have their truth value, as we have already discussed that a statement which is either true or false. Therefore, every proposition have two values. The first one is either true and the second one is either false. Now, when we combine all these things these true value are called truth values. Truth values of any proposition. Now, for example, if P is either true or false. So, true and false are truth value of P, right? Now, we'll discuss what is the truth values of negation. Here we will discuss it through the table which is known as truth table. Truth table. Now, for negation, figure 1, P and Q both are there. It is P and Q. Then, negation of P and negation of if it is true, then it will be false. Negation is false. If it is false, then it will be true. Simple. Negation means whatever the statement, just negation, negative statement of that statement. Now, the second operator is conjunction. What is conjunction? Conjunction, as we have already seen in our previous slide, we are used conjunction for combining two proposition. Now, conjunction means it is similar to the logical and. And what is the operation of that, operational function of that? If P and Q are two propositional statements, then their conjunction is denoted by and, logical and sign. This is the notation of conjunction. Now, if the truth values, number of truth value, let me clear you. The number of truth value is 2 to the power n, where n is the number of variables. Number of variables. Now, these are two variables. So, we have 2 to the power 2 is equal to 4. We have 4 truth values, 1, 2, 3 and 4, right? What we have to do now, we have to make all these truth values combine together with logical and operator and develop the result. So, what we have, how we collect that, how we write that? First, if we are taking two proposition, then true, false, false. Again in the next one, true, false, true, false. If we have 3, then what we have? 2 to the power 3 is equal to 8 truth values. And what we have in this case, true for first one, second one, third one. If we have 3 truth values, right? True, 4 true and 4 false. False and false. Now, true, false, true, false, and then true, false, and so on, right? We have to write in this way so that we can complete it with the help of propositional. Now, let us discuss AND operation. AND operation says that if P and Q are two proposition, then logical AND we say if both are true, then the result will be true. If both must be true. True and false represent false, because there is a false. False and true, again it will be false. False and false, it will be false. So, logical AND represent if both the truth values are true, then only the result is true, otherwise it is false. Now, come to the next logical operator, which is disjunction. It is logical OR operation. It is very similar to the logical OR operation. What is that actually? Logical OR operator, it is denoted by OR sign. It is denoted by logical OR sign. Now, what is the truth table for that? You can say that we have 2 variables. We have 4 truth values for 2 variables. It states that if any of the statement is true, then the result is true. Any of the statement is true. For example, here we have both statements are true. Therefore, the result is true. True and false, it is also again true. False and true, there is at least one true, it is true. False and false, it remains false, right? The next, which is also called conditional, it is also known as conditional proposition. Conditional proposition. Conditional propositions. The next two are also known as conditional proposition. What are that? Implication, which is represented by implies sign, right? Implies sign, either this or this, right? So what is implication? If P then Q, if P then Q. The P is nothing, Q is nothing, but P is nothing, but what is P? P is Q. P represent Q. So the implication sign for truth table of implication is given as, if P and Q are two variables, then true implies true, it is true. True implies false, it is false. False implies true, it is true now, therefore it is true. And false implies false. It statement, it is very, it should be very clear to all of you that if false statement implies false statement, false result, it means that logically the statement is true, therefore it will be true. Is that clear? All these three are very clear to all of you. I hope so. But the last one, you have to remember that if false implies false, false implies false, then together with the complete statement is true, right? So the result will be true. Now the next operator, logical operator, is biconditional. Biconditional, it is represented by implies and is implied by, or in this way, implies and is implies by. What is that actually? It is P implies Q. So what is that? P implies and is implies by. What is that? True implies and is implied by true. Now we have to consider both things. It is nothing but the combination of two implications, right? What are the combination? P implies Q and Q implies P. P implies Q and Q implies P. What is and? If both are true, then only the result is true. Is that clear? If both are true, then only the result is true. Now, P implies Q. True implies true, right? And then true implies true. Both are true. True implies true is true, as we say that. And true implies true is also true. Therefore, the result will be true. Now, P implies Q and Q implies P. On behalf of that, true implies false is false, but the false implies, true implies false is what? False. But the false implies true is true. And the AND operation of these two function, these two truth value is always false. The result is false. Now, the third one, false implies true. False implies true is true. And true implies false is false. Again, in this case, we have false implies true and true implies false is false, right? It will be false. And then false implies false, it is true. And then again false implies false, it is true. Therefore, the result is true. These are all are logical operator which are going to use to develop mathematical logic. Now, logical equivalence. What are logical equivalence? Two statements are said to be logically equivalent if their individual corresponding truth values are very similar. Say, for example, if true, the result of any condition, for example, x, y, whatever the condition are there, true, it is also true. These are true. These are logically equivalent. True, false, these are not logically equivalent. If the result column of both statements have same value, then only the statements are said to be logical equivalent. For example, if P, if it is a statement, suppose it is a statement which is P and it is a statement which is Q. If this one is true, this one is also is true, then these are logical equivalent. If it is false, then it should be false, then only these are logical equivalent. Now, for example, we can say that P implies Q and negation of P or Q are logically equivalent. We can prove it with the help of truth table. Now, we have P and Q and we have two compound proposition. P implies Q and negation of P or Q. So first of all, we have to prepare P implies Q for this truth table. For this 2 implies 2, as this is for P implies Q table, as we already discussed. And then negation of P. We have P, but we don't have negation of P. Therefore, we have to write the truth values for negation of P. Negation of P, if it is true, then it is false. If it is true, then it is false. False, then true, then true. Then negation of P or Q. It is negation of P and it is Q, and we have to apply OR operation among these two. So OR operation states that, as we know, that any one is true, then the result is true. True and false, it is true. False and false, it is false. True and true, it will be true. And false and true, it will be true. Right? Now, check these truth values and these truth values. It is true, then it is also true. It is false, then it is also false. It is true, then it is true. It is true, then it is true. Right? So these statements are said to be logically equivalent. Now, these are some algebra for logical operations. We have to remember that all these algebras, so that we can apply these on various propositional logic. For example, the first one is identity law. Identity law, P and true both depends on P. Why it is? If P is false, then false and true become false. P is already false. If P is true in the second case, then again in this case P or false again depends on P. If it is false, then the result is false. If it is true, then the result is true. The second law is domination law. P or T is equivalent to true. P or T is equivalent to true. It is known as dominant property. Similarly, idempotent law, P or P is P, P and P is P. Idempotent law, both are same. Double negation, negation of any a statement is the statement itself. Therefore, it is known as double negation. P or Q, commutative law, P or Q or Q or it is equivalent to Q or P. Very similar to the commutative law of mathematics in other mathematics. Now, the associative law, we have three variables, P or Q or R. It is equivalent to P or Q or R. Similarly for AND operation. Clear? Next one is distributive law, very important law for propositional logic. These two laws are very important laws, distributive as well as De Morgan's law. P or Q, it is OR over AND. Distribution of OR over AND. Distribution of OR over AND. So what we can write that P or Q and R is P or Q. We will take these two with Q, and P or R. P or Q and P or R. P and, this is AND over OR, very similar to the P and Q or P and R. Now, De Morgan's law, it is negation of combination of logics. So what is this? P and Q, negation of P and Q is equivalent to negation of P or negation of Q. Negation of P or Q is equivalent to negation of P or negation of Q. Similarly, absorption law, it absorbs the values. For example, P or P and Q, it is equivalent to P. We can prove all these statements with the help of truth table by logical equivalent. So let us prove any one of it. Let us prove De Morgan's law, which is very important. De Morgan's law. So what is De Morgan's law? Negation of P or Q is equivalent to negation of P and negation of Q. What we have to do? We have to make truth table P, Q, P and Q, then true, true, false, false, true, false, true, false. What we need now? P or Q. P or Q. What is P or Q? True and true, or any one is true, then the result is true. If both are false, then the result is false. And what is the negation of P or Q? P or Q negation, what we have? False, 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 negation of this one and true. And then now negation of P, and then negation of Q, and then negation of P and negation of Q. These are to be decided. So negation of P is what? False. True. Negation of P is false. True. Negation of P is false. False, then true, and then true. Negation of Q is what? Negation of Q is false, true, false, and true. Now, AND operation. Both are false. The result is false, again false, and then true. Now, see the result. See the result. False, 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 and true, right? So we can prove all the identities which are given state previously by truth table. Now, what are tautology? Tautology are those statements which have only true value in their last column result. All the result are true. For example, P and negation of P is a tautology. Why? The result contain only truth value. Clear? Next type of propositional statement is contradiction. The compound proposition is said to be contradiction if it has only false in the last column of the table. The contingency which have mixed value of true and false both. For example, all these three are true, but the fourth one is false. So this statement is known as contingency. Tautology, contradiction, and contingency. Now, elementary normal forms. What are normal forms? These are very important to convert one type of propositional compound proposition into another types, right? So what is normal forms? So before normal forms, we must know what is elementary product and what are elementary sum. So AND operation is taken as a product, right? So any proposition with negation, right, is treated as a elementary product. Compound proposition, it should be compound proposition, is treated as a elementary product if it has AND operation among them. These all are elementary products. P and negation of P or Q. These all are elementary products. Elementary sum which have OR operation. OR is referred to the elementary sum which have all operation, OR operation. For example, negation of P. P is also treated as a elementary sum as well as the elementary product because this should be keep in mind. P and P is equivalent to P. We have already discussed in the algebra of proposition, and P or P, it is equivalent to P, right? So again, P can be treated as a elementary sum as well as the elementary product. Negation of Q or P, negation of P or Q. These all are elementary sum. OR means elementary sum, AND means elementary product. Only these two things you should keep in your mind. Normal forms. There are two types of normal form, basic normal form, then we will discuss the further enhancement in their normal forms. They are conjunctive normal form, which is known as CNF also, and disjunctive normal form of, right? Conjunctive normal form and disjunctive normal form. What are those? Let us discuss conjunctive normal form. Conjunctive normal form is what? A compound statement is conjunctive normal form form if it is obtained by operating AND among variables. Negation of variables may be included, may or may not be included, right? So it is AND, it is AND, it is AND, right? These are known as conjunctive normal form. Disjunctive normal form, a compound proposition statement is disjunctive normal form if it is obtained by operating OR among variables. It is obtained by OR among variables. OR. It should be OR. It should be OR. It should be OR. Right? or among variables, then these are known as conjunctive normal, disjunctive normal form. So in conjunctive normal form, we have to find and operation. In disjunctive normal form, we have to separate by or operation, right? So this is this is all about the lecture for today. We will discuss all conjunctive normal form and disjunctive normal form in the further lectures. Thank you.